Hello everyone. This is my week 11 presentation, and today I'm going to present the solution to problem 7.2.3, and it reads as follows. Exponentiation is repeated cumulative multiplication. Y raised to 0 is 1, and y raised to x plus 1 is y raised to x times y. So that for positive x, y raised to x is the product of x, y's. Using 7.3 as a black box, design a program for exponentiation. For context, figure 7.3 is here. And notice that in figure 7.3, this program uses the lossless adder of figure 7.2b, which is shown here, as a black box for the multiplication program, because multiplication is basically repeated addition. And we're gonna do the same concept here with this program as a black box for the exponentiation program, because exponentiation is, as the problem said, cumulative multiplication. And with that, let's go to my program that I wrote. And let's just move to that one. And yes, I wrote it in paper. So let me explain here. So this part right here, the one enclosed, is the multiplication box. This whole thing. And I just did this so I can easily visualize what is about to happen. What you so what what so I can basically visualize what is happening between the registers inside. And so for your solution, what you're supposed to do is you're gonna disregard the registers inside, then just put a multiplication box right there. And for the exponentiation program, basically what I added is this three parts right here. How can I draw on this one? Basically, these are the three subprograms that I added for the program. So, and these three subprograms, I named them number 1, number 2, and number 3. So I can explain them in detail. So program number 1 is that what it does is that it it empties A, register A, and it puts its contents in register B, in register E rather. And I forgot to tell you this, but for this exponentiation program to work, this should be the contents prior to the registers. So the the base should be in register B, and the exponent should be in register A. And with register C, D, and E should be 0. And the program after it is computed, register A should have the answer, y raised to x, with B still having the base, and all other registers 0. So again, let's again continue with explanation. For subprogram number 1, what it does is that the contents for A, which is the exponent, it puts it into register E while emptying register A. And that process continues until it is empty. And for number 2, register A is added 1 stone. That because if we leave A empty, then the multiplication box tells that the multiplication box also makes uses of registers A and B, with A and B as two of the multiply as the two parts of the multiplication process, and with A as again having the product. So if we're not gonna add 1 stone to A, then for the entire process, the result for everything will be 0. So we have to add 1 stone to register A. And so for part 3, every time that so for part 3, so register E, which contained the contents of register A prior, is now deducted 1 stone, and every time until and when it's deducted 1 stone, the process will go to the multiplication box. And so the multiplication box basically that since it multiplies the contents of register A and B. For example, we have currently we now have 1, y, and for E we have x minus 1. Oh no, prior to that we have as of this points before as of this point before we just subtracted 1 stone from E, we currently have 1, y, 0 for C and D, and currently x for what for register E. Now if we're going to now for the sub for the for subprogram 3, this 1 stone is deducted from register E, and then A and B are multiplied together. So for the preceding setup now, after that we're gonna have y 0 0 and then x minus 1, and then the process continues until E is empty. And in that case, the exponentiation process has finished, and then we are going to be left with y raised to x on register A, y on register B. So that is the program that I wrote for problem 7.2.3.